Okay, well, we'll go ahead and start as a couple more folks coming in.
Yeah, usually we get a few more in the first 5 minutes.
Got it. Okay, so I want to talk about, just talk, so cyber resilience is something I've been looking at for a while. And the question is, Tom Friedman was here a few months ago, talked about the age of accelerations, of a variety of accelerating changes we get to, so how do these come together? 6 parts. What is resilience and what does resilience mean in this time of rapid change? I'll spend probably more time than you want me to on this because it's important, I think, to establish a baseline. Then how does cyber fit in this? How do you plan and engineer for it? And then some other aspects. And then how do you become a cyber resilient organization, which we may or may not get to. So basically, most people don't understand resilience. They tend to think about bouncing back to some status quo ante before the event. It's not the same as risk management. It's not a plan or a process. It's a long-term strategy that leads to capacity. An organization has a capacity for resilience. This is a resilient organization. It's the outcome of it. It's not the same as corporate succession planning or continuity of operations or supply chain risk management. It is, in fact, this capacity. And I had the vice president of a fairly large international company a while back saying, in 30 years of business, I've never used the term resilience. I've always focused on corporate succession planning or continuity of ops or risk management. I've never tied it together in resilience, and that's what we're trying to do here. So Judith Rodin, who was the former head of the Rockefeller Foundation, has a pretty good definition. Again, the capacity of any entity, person, community, organization, natural system, to prepare. The repair is really important for disruptions, recover from shocks and stresses, and then adapt and grow from the disruptive experience. So basically, be prepared to bounce forward better. You're not bouncing back, you're bouncing forward into some new post-status, post-disruptive status. The 2 parts here is how do you build the capacity and how do you adapt and grow. So in the graphic, here's where you were before, here's the disruption. You degrade to some amount, you claw your way back to kind of a degraded operating system, and then eventually you respond, but you restore, but you don't wind up where you were before. You want to wind up in a better normal, and that better normal is focused not on where you were at the beginning, but where you were in this changed environment that you're now facing. Compared to security, security is actually about locking up and hunkering down. How do you protect? How do you keep bad things from happening to you? On the other hand, resilience is about achieving the organization's goals. It's about, under any level of shock and stress, it's about fighting back, emerging stronger. So the attitudes are really quite different. Security, you want to protect. Resilience, you want to take the stresses, keep fighting. And this is something the leadership has to do at all levels. I mean, people, everyone from the person on the shop floor all the way up to the boardroom has to be thinking about this way. You have to nurture and make this sustainable. One of the problems you see with many charismatic CEOs of large companies is the company's doing brilliantly and the CEO leaves and you have dramatic declines in performance because they haven't made it sustainable across the organization. It needs to be resourced. It's a positive business asset. And again, you're trying to build this enduring capacity. Tom Friedman, quoting Darwin, has an interesting point. It's not the strongest or the smartest that survive, the most adaptable. How do you make your organization adaptable in these changes? Nassim Taleb, who gave us black swans, also has this construct of anti-fragile. And how do you look for those things that actually thrive and benefit from stresses and shocks? There is no silver bullet. You're going to have the foundation of the culture has ethics, principles, governance. Compliance is not just checklists. Compliance is understanding what you were supposed to be doing and then understanding how what you're doing differed, what happened to you differs from what the baseline was. Details are important. It's not enough just to have general threat intelligence out there. You need to know the specifics about what's trying to go on in your networks. How many of your subcontractors are actually compromised, things like that. A lot of times people have comforting indicators but don't really help them. Cyber dashboards may look great, but are they actually addressing the malware that's already in your supply chains? That may already be there. Standards and regulations are terrific. Are you actually complying with the current standards, and actually are people paying attention to it? Reporting change, you see all the time. Leadership, things are just great. The hardest thing I had when I was in command of a warship was to get bad information early enough to keep from falling off a cliff. After something goes wrong, everybody says, "Oh, I knew about that." Well, how do you find a way to get that to bubble up to the top? You need to be promoting continuous improvement. Remember, you can never say a lesson has been learned until behavior changes. A crisis happens, you observe a lesson. Next crisis happens, you re-observe the same lesson. You keep re-observing the same lesson. So how do you change behavior, educate, incentivize, whatever, to cause people to do things differently? You've got to exercise and test your solutions against challenging scenarios. It doesn't do any good to pick a really easy solution, test it and say we passed. Test against a challenge. And lots of times the problem is that things are going really well actually are not very resilient. The people and the organizations become brittle because as soon as something goes wrong, they collapse. A friend of mine used to be the head of the Singapore Navy. He's now head of the subway system, the metro system in Singapore. He says, never had so challenging a job because the people of Singapore are used to having everything work. And when the trains don't depart on schedule, he starts getting swamped with social media. Okay, well, what happens when things do start going wrong? How do you build a resilience in the population? Says, okay, we're going to fight through this. We're going to keep going. About 3 months ago, I was in Manila, and they're getting ready for a really big earthquake. They're expecting 30,000 dead, 100,000 injured in a quake in the next 25 years or so. And the question is, who are the resilient people? It turns out the most resilient people in Manila are the ones who live in the barrios because they don't have anything now. And so when everything collapses, fine, they continue the way they're doing business, whereas the people who live in the high rises are the ones who fall. Persistence, this may take years and many iterations to get to. So there are two different types of resilience. There's a cultural resilience and there's an operational resilience. The cultural resilience is, will you maintain your composure and keep fighting with regard to the situation, or do you give up? How do you keep that up? Healthy culture promotes resilience from a long-term perspective, and the labor force is key. One of the jobs I used to have was to help evacuate the Defense Department people from Washington out to places like Raven Rock, which is the nuclear command and control bunker. And they had weeks of water and weeks of fresh, clean air and weeks of food and all kinds of computers. Nobody paid attention to what was happening to their families. How attentive do you think your people are going to be locked up in this secure bunker, knowing their families are unprotected? So how do you think through the resilience of the individuals and their families before the fact? Right? The business resilience is what people normally think about resilience. It's tied to the technology and the systems. Are your systems secure? Cybersecurity can make your networks and systems more resilient. Critical infrastructure can be protected. Cross-functional teams can look across stovepipes. And it's actually much better if you work outside your organization to engage in your local community. The mayor of Norfolk and the Allied Command Transformation about 6 months ago, about a year ago, had a really, really interesting conference called Interdependencies and Resilience. And the mayor of Norfolk started this off by saying, General Mercier, the commander of the Allied Command Transformation, you may think you have a resilient command, but if my city streets are flooded and your staff can't get to the headquarters, you don't have a resilient command. How do you think through those kinds of interactions with people who are not in your organization ahead of time? The Defense Department has a concept called mission assurance, which is very much like accepting damage, fighting back at any level. But it's actually much more sophisticated than that, because it's not just tactical fighting back. You've got to think about security, protection, risk management across the entire life cycle, from the acquisition all the way through decommissioning, of how that system is going to be resilient, how it's going to fight back. Again, the goal is to fight hurt, restore quickly, but again, it's not just tactical, it's across the entire life cycle, configuration, control, training of the system. All right, so turning this age of accelerations. one of the things happening is the structure of risk is changing. All over the world, confidence is declining in government and expert advice and businesses for a number of really good reasons. We have businesses that have covered up cyber incidents or covered up fraudulent practices, or whatever. These things challenge our confidence in leaders, and of course the social media, political processes, 24/7 news cycle just reinforces this. So against this background, the World Economic Forum, Davos in Switzerland, has postulated a fourth industrial revolution. This is Dr. Klaus Schwab, of the head of the World Economic Forum. And the argument is there's going to be increasing geopolitical risk, accelerating technological change, and interconnecting a whole batch of technical and social risks. So the first industrial revolution in this model was in the 1780s, and it was the incorporation of steam and water to mechanized looms, to railroads, things like that. The second was about 1870, where electricity led to divisions of labor and also mass production. The third was late 60s, early 70s, what we call the information revolution, semiconductors, computers, networks. The fourth, which he argues is just beginning, this was a 2016 article, is that the converging, accelerating technologies are actually blurring the lines between the physical, the digital, and the biological spheres. We're already 3D printing organs that are being implanted in people. The bladders, for example, almost all orthopedics in Europe are 3D printed, things like that. So much of the bioinformatics and all that hinges on digital. The lines are blurring with major consequences. So some of the key distinctions. Third is information. We think we understand this. The fourth is the velocity of change, scope, and systems is going to be massively disruptive, accelerating. And it's not just going to affect production, it's going to affect management. How do you manage this intersection of physical and biological and information worlds? Lots of collective benefits. The pie is almost certainly going to grow. Productivity is going to increase, but also it's going to negatively affect many people. More and more studies show the division of hollowing out of the middle class, the lots of low skill, low paying jobs, very few high skill, high paying jobs. What are the social impacts of that? Machine learning and artificial intelligence, the pace of change is getting to the stage beyond which many people can adapt. So the responses have got to be public and private, whole of government, whole of society, really transnational, comprehensive and integrated. Nobody has all the answers. So if you think about the velocity of tech change, pick a parameter, say computing power per unit cost. Let's say it's doubling every 18 months. Okay, in a year and a half, you have 100% more capability. But in 5 years, it's 900%. In 10 years, it's 10,000%. 15 years, it's 100,000% change. I have no clue what 100,000% change of this thing is, but I'm sure I'm not going to be lugging this brick around with me. Okay? So, all right, that's just a straight exponential curve. Now, this thing may level off, could accelerate. There may be discontinuities with quantum computing and stuff like this. But the point is, linear projections cannot work. And part of the problem is we tend to linearly extrapolate where we are from where we started, or where we're going from where we are now. Biology is changing even faster than information. The cost of sequencing the genome is down 6 orders of magnitude in 10 years. Robotics becoming ubiquitous, nano is poised for breakout, energy impacts are global. I tend to think in terms of brine, bio, robo, info, nano, energy, and how they interact together. And you could toss on that now added manufacturing, artificial intelligence. So again, linear projections of where we are now cannot work, and we have to factor that in our planning. So some of the security issues out of this fourth industrial revolution: raise incomes, improve quality of lives, much more unequal, disrupted labor markets, low skill, low pay, high skill, high pay, social tensions. Right? Service jobs are going to be particularly vulnerable to automation, and that's some 80% of the developed world economies. McKinsey talks about 5% of all occupations can be totally automated, but 60% of all jobs today should have 30% of their content automated with today's technology. So it's not going to be replacing people by machines. It's how you get people and machines to work together. And that, again, is part of the cybersecurity thing we'll get to in a little bit. So for countries like Germany, Japan, South Korea, robotics, good deal. The workforce is aging, declining, so on and so forth. What does it mean for the youth bulge areas, Mideast, North Africa, Sub-Saharan Africa, South Asia, if there are tens of millions of young people with no entry-level jobs, hence no stake in the international system? We saw 1 million refugees overwhelm the European political system in 2015. This potentially is many times more than that. High potential for domestic unrest, scapegoating, radical nationalism. The economist has a great discussion of this and says, unless governments and the private sectors are really skillful in managing these changes. And unfortunately, our track record of doing this skillfully is not particularly good. In addition to threats and security architectures, people talk about the center of gravity of conflict, tanks, troops, artillery, command posts. In fact, the center of gravity of future conflict may be shifting to the resilience of the populations, the engaged nations. We can reach out directly to the minds, living rooms, and mobile devices of the populations and address their willingness to stand up and fight, as opposed to just attacking the military forces. Core issues for alliances. Threaten possible deglobalization. Look at local production. We can already 3D print. 3D printing is moving away from printing one-off prototypes to beginning to print at scale. Why have all of your inventory tied up in container ships going back and forth across the Pacific if you can reshore your productivity? Reduce labor force costs. Somebody has a cobot, and it's like $30,000 to rent for 2 years. It's a production robot. And if you run that out, that's about $4.75 an hour at one shift, and it's about $1.75 an hour if it runs 3 shifts, 24/7, 365. So just stuff that's already out there can dramatically change the dynamics of the workplace. Almost all the new energy production that's being installed is being dominated by local sources: solar, wind, hydro, and fracked natural gas, not stuff shipped all the way across the world in tankers in the Persian Gulf. Explosion of productivity in urban and indoor agriculture. In Tokyo today, they're growing 10,000 head of lettuce a day in a soccer stadium in downtown Tokyo with 1/10 the input of water and nutrients, and that's 365 growing season. It doesn't matter if the monsoon fails, El Nino, La Nina. What is that going to do in terms of, again, localized production? Again, trade pacts, balkanization, the internet. There are lots of reasons why this can have negative impacts on globalization. These are trends the governments can't control. They can only influence. And people question is, how do you, what does it mean for a whole national security strategy, culture, and organization? That problem is a lot of our governance is based on systems that were really designed during the Second Industrial Revolution. Okay, during the time of mass production, during the time of industrialization, when you had time. When an issue came up, to sit down and study the issue, to convene a working group, to develop measured responses and regulate. We don't have that luxury anymore. How do you govern in the face of these changes? Not even govern, how do you, as a business or as individuals, how do we manage our lives? These trends support the hybridization of warfare, moving together unconventional warfare, conventional warfare, psychological warfare, things like that. Individuals anywhere are being empowered. Non-state actors. One stage, cyber, autonomous, biological weapons. Somebody pointed out, imagine that there were 200,000 people in Seattle. Imagine that 1% of those are technological geniuses. That's 20,000 technological geniuses. Imagine 1% of those are raving sociopaths. That's 200 raving sociopathic technological geniuses in one American city with access to cyber, autonomous, and biological weapons. Where's the line between combatants and non-combatants? And this whole issue about cognitive emotional conflict, it's not just cognitive as rational thought. There's a huge emotional conflict to this whole thing. So the impact is going to be of the fourth industrial revolution largely on people. Not only what we do, but who are we? These are issues, biotech and the AI revolutions. What does it mean to be human? You're redefining the thresholds of human lifespan, health, cognition, capabilities, really compel us to address some really serious moral, ethical boundaries in the course of this revolution. Okay, so what does now this imply for cyber resilience? So again, we talked about organizational, operational resilience, which is the systems and networks of 5 organizations. In cyber resilience, the World Economic Forum a few years ago said, cybersecurity is not enough. Cyber resilience has got to be considered a strategic goal, part of a strategy of defense, prevention, and response. Some of the principles: recognize the interdependence of everything. Just start with, for example, the Internet of Things. Okay, the water systems, the power systems, the transportation systems, the medical systems are all inexorably being linked together. So how can you foster a shared digital space? Again, we talked about earlier the role of leadership. How do you manage cyber risks? If your culture, coming back to this culture, is going to be, oh, we have a violation, we have a compromise, let's hide it, let's not talk about it, let's cover it up, you are not going to build a resilient culture in the cyberspace in the organization. Integrated risk management, tie this together. And the uptake is, how do you encourage awareness of this and commitment among your customers and your suppliers, as well as your own organization? Many of the compromises we see today are not occurring in the primes, they're occurring at a level of second and third tier subs. So how do you get your understanding of resilience down to that level? Probably won't get to it here, but the C4I and Cyber Center here has also been talking about community resilience, and we've recently set up a lab here in Bogeno for community resilience. The key point is the cyber resilient organization has got to be part of an organization that's resilient overall. It's not just a technological problem. Remember, sociology always beats technology. Cybersecurity contributes to cyber resilience, but the resilience is much broader than security alone. And you've got to address more than technological issues today instead of the cultural and the information components of it. With regard to conflict, this adds lots of conflicting concerns. Offense versus defense, or in cyberspace, what's offense, what's defense? We talk about active defense, where you preemptively, strike back before somebody launches the denial of service attack. Is that offense or defense? The whole civil-military boundaries are blurring. Technology versus policy. How do you tie together the incredibly rapid changes in technology with the fact that policy almost certainly cannot keep up with them? Okay. What do you do? Best practices. It even challenges traditional concepts of war. War, traditionally, proportionality, attribution, mutual destruction. Does that apply in cyberspace? What parts would apply in cyberspace? I was involved over the weekend in a really interesting discussion about what parts of the recently announced U.S. national cyber strategy tie into traditional concepts of sovereignty. And we can spend a whole talk on that, but the bottom line is there's a lot of ambiguity. And the way the U.S. is interpreting its national cyber strategy defensively would be seen as a violation of sovereignty by lots of countries. State versus non-state actors, and military versus dual use infrastructure. To what extent are cyber attacks on power grids actually legitimate kind of forms of hybrid or operations short of conflict in the present cyberspace environment? The cyber attack chain is pretty standard. Reconnaissance phase, weaponizing the payload, delivering the payload, exploiting it, installing your malicious software, command controlling it, and then act on the objectives. One of the things that's interesting at DEF CON every year is somebody reported on how they can now, the hacker community has actually automated the entire cyber attack chain. It used to be that the biggest problem for the attacker was to laterally spread within networks, identify the location where you could take over and elevate your permissions. Anyway, several hacks were demonstrated last year that showed how to do that. So this thing is now basically, we'll talk about this in a minute, forcing you to fight at machine speed, not at people speed. OODA loop, observe, orient, decide, act. Historically, the observe part was somebody standing in a cockpit looking at the other fighter planes or standing on the hood of their vehicle with binoculars. Orient was you saw something and you tried to figure out how it fit in the big picture. Increasingly, these are electromagnetic. The information is delivered from electromagnetic sensors. Decide and act increasingly is supported by information processing. The point of this is cyber can dominate the OODA loop in all domains: land, sea, air, space. Okay. Technology changes. We talked about processing power increases, the velocity of machine learning, the proliferation of sensors. People are talking about 20 billion information, Internet of Things sensors by 2020. I saw something the other day that talked about what does the insurance industry do in a world where there are trillion sensors, where there's virtually no ambiguity about what's going to happen. It's not statistically where the accidents are going to happen. You know when the accidents are going to happen. What does that do to insurance? And then the speed of decisions. I was part of an Army study about 2 years ago of the battlefield of 2050. And the question was, in this world of proliferated sensors and precision weapons, can you move and not die? And if you can't, then what does that say about the battlefield as we traditionally understand it? Speed of decisions. The Air Force increasingly is talking about human on the loop versus human in the loop. So instead of waiting, we like to use humans in the loop, waiting no lethal decisions can be made without a person pushing the button. In point of fact, the conflict is going to have to be fought at machine speed. And if you wait for the network graph to turn from green to yellow to red, you've lost. So how much authority do you delegate to your autonomous systems and the human on the loop system? And at what point do you cross the threshold of saying, yes, the machine can take this action? So cybersecurity, traditionally confidentiality, integrity, availability. We spend a lot of time on confidentiality, but the point of fact in command and control systems, the integrity of the data, that's absolutely crucial. If you want to completely take control or cause somebody to lose confidence in their command and control systems, cause them to lose confidence in the data in that system. Perimeter defenses, we know we can't build higher walls and wider moats with angry alligators. So what are some alternative approaches? Most industry right now is looking at big data analytics, where you look at everything that's going on in the company and you look for anomaly detection. I mean, why as well as in accounting trying to see what the R&D people are doing, that sort of thing. What information is trying to be exfilled. And if you saw or not, but there's been a major focus in the last couple months on our supply chain vulnerabilities. And this is not just, and so some of the things people are talking about is, could you use, we use blockchain-like, because blockchain has a lot of hype associated with basically cyber secure distributed ledgers to keep track of some of the supply chain. Again, policy, legal, moral, ethical, privacy issues are inherent in this whole thing. So what are some of the real world examples? How many of you have seen the videos of the Aurora generator test? So in 2007 at the Idaho National Engineering Lab, they did a cyber test on a generator. It's called Aurora. This was not supposed to have been released, but it's on YouTube. And basically they took the rotating part of the generator and pulsed it 60 degrees out of phase with where the rotating machinery was. And as you watch the generator, in about a minute and a half, it just physically tears itself to pieces. And the point is, it's the physical destruction of equipment by cyber attack, which is what was done in Stuxnet. In addition, with Stuxnet demonstrating you can bridge air gaps as well. Iran responded with the Shamoon attacks on this, destroyed thousands of Saudi Aramco computers. Of course, the Iranian power grid was dropped right around Christmas time in 2015. The Navy in 2015 convened something called Task Force Cyber Awakening, which was based on a combination of some of the exercises the Navy did to look at their own vulnerabilities and also real-world penetrations of Navy networks. And they came out with actually a pretty good report on cyber resilience for Navy that's worth looking at. In 2016, the distributed denial of service attack on DynCorp, trillion attacks per second based on the compromise of basically security cameras. Okay. The botnets. WannaCry in UK, National Health Service, the ransomware. Meltdown Spectre now has software and firmware bugs. And then there's been something in the U.S. National Defense Authorization Act for the last year or so talking about reshoring the production of chips in the United States. We no longer have any significant chip production capabilities. The question the Congress is asking, do we need to spend the money to reshore that chip? Can you actually trust any chip that's made overseas? From DEF CON, my wife and I go out there every year. There is absolutely no reason of complacency. Actually, nothing I ever learned there makes me sleep better at night. Growing in from automation, AI, machine learning, but there's lots of hype. Frankly, the companies that say we've got AI built into our systems, lots of times are building it into the user interfaces rather than into the really serious analysis work. Be careful. Speed is emphasized repeatedly. What do you think the average time to detect malware in a network is?
Seconds.
The average time for a company to detect malware in its network is ranging between 140 and 200 days. And then once the malware is detected, remediating it is taking another 140 to 200 days. It's absolutely mind-boggling. And so the question is, how can you remediate the flaws faster? How can you aggressively update the code? And there's some really good work on this, but this time is just absolutely amazing. Infrastructure, I mentioned destruction of service. That's what the Aurora showed. And then the IoT weaknesses. Part of the problem in the IoT is there's no demand in the marketplace today for anything other than functionality and speed to market. There's no demand for security in the Internet of Things market. Some people are just beginning to talk about new protocols and things. By and large, it's not there. So many newer systems are being run by software-defined radios and software-defined networks. There are ways to secure these, but they really require skilled people who know what they're doing, and importantly, can integrate hardware and software fixes. And part of the problem is when you're dealing with SCADAs, the Supervising Control Data Acquisition, and the IT-OT integration. So IT is the TCP/IP. The OT are things like generators and air conditioning units and doors and sensors and valves. Most people know how to do that very well. So if you're going to plan and engineer for resilience, there's actually been some interesting work done at the University of Manchester of all this place on this. So whole of society, public, private, whole government, transnational. You've got to look at the physical and the cyber and the human and the time dimension. The scenarios when you test your systems. What are the threats, resources, tech change, political will? Try to look ahead. Don't just look where you are now. Extrapolate out the velocity of change we talked about. Look at the cross-sector vulnerabilities and dependencies. Cascading casualties, what happens when the power grid goes down. One of the problems with Hurricane Sandy in New York was that there were a number of gas stations that had gas but no power to pump it. And there were a number of power stations, or gas stations that had power but no gas. But there was no integrating information network to tell you which was where. So how do you tie that sort of thing together? Stakeholder mental models, training and exercises, education incentives. Again, you've got to change behavior through whatever combination. And Navy, I think, did a pretty good job of this in Task Force Cyber Awakening. One of the things that came out of that was the cyber resilience of the U.S. Navy is not the responsibility of the CIO. It's not the responsibility of the SIX, the communicator. It is a command responsibility. The cyber readiness of his vessel or her vessel is just as much their responsibility as having enough weapon systems or having enough fuel or having enough training. Again, designing in is almost always the way to go. So there's a very interesting model that came again out of Manchester here, IEEE, and it talks about phi lambda epsilon pi. And in this, in a power grid example, phi is how fast the grid degrades. Okay, so here it's degrading. The lambda is how low does it go. The epsilon is what's the extent, how long does this last, and then the pi is how promptly does it come back up. And given our model here of winding up bouncing forward better, it had two additions which in this case would be how much better is a wind up, beta, and how long tau is taking to get there. So you can think of a phi, lambda, epsilon, pi, beta, tau model. And there actually is in the IEEE paper some really interesting analysis of this, the power grids, to show, okay, I can design my power grid to be robust, so it won't crash, or agile, so if it does crash, I can bring it back quickly. And they actually do the analysis of how many total hours of lost power time you get under different strategies. So we're looking at how you might apply this to cyber resilience.
But it looks like this graph of degradation, it looks like a conceptually linear graph, but it's building infrastructure, it seems that more of a collapse. Perhaps building infrastructure.
Yeah, and so the way the analysis does, it actually looks at areas under curves. And so this can be any shape you want it to be. It just looks at the total area, compares the total area under curves in terms of amount of lost power over time. So this is linear, but yes, the real world will be very, I mean, it could well be punk, or it could be step, or it could be whatever. So if you're doing resilience analysis, okay, so 5D, deny, disrupt, create, destroy, deceive, lots of different types of attack. Over 200 different vulnerabilities are identified against human-machine interfaces alone in the supervised control data acquisition system, DDoS, penetration, firmware, supply chain, social engineering, cleared deciders. But again, collectively, it's really interesting to see what you can do with, like, say, a chemical plant, where you wind up attacking this way and they wind up producing impure chemicals, and they wind up leading to explosions of processes. One of the interesting things out of this is that a large percentage of the generators and a large percent of the industrial controls in the United States are still running on XP. And the reason for that is because when you test a chemical plant, we bring it online, you test it and you make sure no bad things happen, second and third orders. And once you have that operating, you don't want people going in there and patching and putting in new systems. So lots of times the contracts are actually written prohibiting you from updating them, with the result now you have these horrifically out-of-date systems. There are some interesting analytical approaches. The key point is, how critical is a system? For example, in a submarine, there are 4 ways of generating oxygen. There is an oxygen generator, which they usually have 2. There is a candle, which is somehow you burn it and it generates oxygen when you burn the candle. There are flasks of oxygen you can open up, and there's a snorkel you can stick up and bring oxygen in the boat. Okay? So the point is, the generators can be hacked. Got it. But you've got 3 other ways to get oxygen, 2 of which are unhackable, essentially. You can just open the valves on the pipes and light the candles. And so rather than spending gazillions of bucks and everything on this, just ask how critical is the system to the overall success of the mission. There's several really good tool sets to analyze this. DHS's cybersecurity evaluation tool is actually one of the better ones, and it takes you through both high-level and detailed questions about not the IST, but also the OT systems. And there are others from other organizations. There's a commercial products that give you a cyber risk score that's kind of like a, your financial credit score. These may become more and more important as cyber insurance comes to pay. What's your cyber risk score? Okay, we give you lower insurance rates. And I think eventually cyber insurance is going to become really important in terms of adding a basically financial way of measuring some of the impacts of cybersecurity. Again, here's 5% of DoD security spending is for the operational technology, and the generators and the sensors and the programmable logic controllers and that. But there are 250 times as many of these things as we have IT and IS systems. So even though the vast majority of our vulnerabilities are in these OT systems, the vast majority of our spending is in the IT systems. So you think about humanitarian cyber. This is just interesting in the sense that there are 28 different definitions of cyberspace, more or less. The only thing that's common is digital networks. And so the question is, how do you keep digital networks operating across the full range of a crisis, before, during, after, long-term restoration? And so when you talk about cyberspace humanitarian operations, comms, lift, and power, right? People get wrapped up in delivering major muscle movements like food, shelter, water. But if you don't have the communications to understand where the vulnerabilities are, you're going to deliver the wrong things to the wrong place. In order to have that, the comm's almost always going to need power, and you're going to need some way to lift it to the area in place. This almost never gets thought about during the first 72-hour rescue phases of a disaster. You have lots of diverse components. Every NGO, every state, every National Guard have different systems. You've got to think about spectrum, and people almost never think enough about spectrum in this environment. And then again, you have different types of attacks. The other thing to think about in the humanitarian is humanitarians think of themselves as doing good work, but in point of fact, in any kind of crisis environment or conflict environment, what's humanitarian assistance to one side is strategic war material to the other. And so the humanitarians themselves very quickly and often become the target of malicious behavior. Cognitive emotional conflict, we talked about that earlier. Basically, it's not enough just to focus on tangible things. How do you affect the minds, mobile devices, and resilience of the population itself? If you look at the spectrum of conflict, measured short of armed conflict, some people talk about gray zone today, which can think about the Ukrainian power grid, all the way up through terrorism, irregular warfare. Hybrid is the mix of conventional warfare and irregular conventional major theater war. In this case, the probability up here is low, high at the bottom, but the level of violence is high out this way. This kind of cognitive emotional question, again, which cyber plays directly into, runs across the full spectrum. Organize, train, and equip. Prepare for the war, not just for the battle. The Imperial Japanese Navy on December 7th, 1941 was completely prepared for the battle it was about to fight, completely unprepared for the war that was about to envelop it. As we look at the money we're spending on fighters, and I love F-35s, I love DDGs, I love aircraft carriers, but how much are they really contributing to these non-traditional missions of the cognitive emotional conflict? The equipment is changing rapidly. Personnel skills are in very high demand with the private sector. How do you maintain your government techies? Training has got to be multi-tiered. It's not just the techies. It's got to be the leaders and also the people who are on your networks who may not have anything technical to do with them. Difficult policy, ethical, moral questions, lots of legal issues. How do you apply the law of armed conflict? And again, in cyber espionage, there really is no rules of the road. It's Wild Wild West out there. The cyber capabilities I mentioned cut across domains, land, sea, air, and space can be dominated by cyber. And we have a tech, frankly, a generator goes down. The generator tech's not going to think of a cyber attack. He's going to think, what happened to my electromechanical systems, the fuse blown, whatever. How do you train your people to think about that? One of the things that's going to add lots of further complexity is the convergence of cyber and electronic warfare, or as people are starting to talk more electromagnetic spectrum warfare. Again, let's talk the whole other lecture, but one of the interesting things is the analog digital interface. Electronic warfare, jamming, things like that traditionally has been the province of analog engineers. Cyber has been the province of digital engineers. Getting them to talk to each other is really much harder than you think. Cyber on cyber is rarely the most effective. Cyber in conjunction with some other form of hybrid warfare is what generally you're going to see. You need to do this collectively, share data. I did a simulation of an attack on the Japanese Olympics recently, and the Japanese are tend to be a very stovepipe country. They don't share data, at least in the cyberspace area, and it was a really fundamental problem for them. You've got to share the information. And then again, focus on the resilience and mission assurance, not just on the security. Public-private, nobody has all the answers. How can you empower businesses to protect themselves when the attacks are coming from overseas? There are these things called ISACs, Information Sharing and Analysis Centers, which were set up 20 years ago to try to encourage sharing between the public and private sectors. By and large, they haven't worked. The key question is, how do you build trust among them? And then, so if you talk about how to build a cyber resilient organization, one of the things Navy came up with in their task force, Cyber Awakening, boundary control points and segmented enclaves. So there are lots of ways to get radio frequency information into a ship. And a lot of times people have not been thinking about it as a vector for cyber attacks. Well, now they're realizing it. So you need to have boundary control points for each thing that comes into the ship is some kind of protection on it. But then the internal enclaves, you can't just, once you get inside the ship, go anywhere. How do you build those in? Incidentally, this is exactly the same model that Tesla uses in the cybersecurity for the Model S, which the hackers themselves have said is the best cybersecurity model they've seen in an automobile. Secure microgrids, cybersecure microgrids. Defense Department did a test program a couple of years called Spiders, which was cybersecure microgrids at DoD facilities. Now they're looking to migrate it to the private sector. One of the things that was really interesting 2 or 3 years ago at DEF CON is DARPA had a cyber grand challenge where they actually had a capture the flag exercise where you look for kind of a hexadecimal flag that was entirely done by supercomputers fighting each other, 7 supercomputers fighting each other. And the team that won basically said we used several things. One was essentially cybersecurity of binary. As they didn't they understood how to analyze the binary and never let the malicious code compile, was one. Second, formal methods, where basically you can actually write mathematically secure code for some things where you can mathematically prove that these algorithms are secure. DARPA has been doing a lot of work on this. That's starting to roll out. Right now, there was a case a couple of years ago where they took a drone helicopter and they had 2 modules, a mission payload module and the control module. And the control module was written in formal methods software. And basically they gave it to the hackers for 6 weeks, flew it into the most intensive environment they can think of. The mission payload was shredded almost immediately. They never were able to succeed in breaking the mission payload control, the mission control software. Near real-time anomaly detection, Hawaii Electric Company, a couple of years ago, is now implemented what they call supervisory phasers. There are 2,000 measuring devices of the phase differences between the 3 conductors of the grid. And so measuring several hundred times a second. So actually getting a near real-time picture of anything that goes wrong in the grid. They don't care whether it was cleared insider or mechanical failure or hack or whatever, they just need to know what's happening. Workforce education. How do you figure out this explainable AI is going to become more and more important. I think we have a talk this Friday on explainable AI. This basically, if you're ever going to establish trust in artificial intelligence, people have to understand how it came to its decision, and the software has to explain how it came to its decision. And then again, focus on real world threat intelligence. Almost every one of these approaches is going to be iterative. The problem is these interdependencies are usually part of complex problems, sometimes called wicked problems. And so the minute you begin to go solve part of it, you change the problem. Okay? And so the way you address this is you document your going in assumptions. So whether it can be political, the Iraqis are going to greet us with open arms across the border, or Iraq or Afghanistan can become a democratic country, whatever. You document those, and you keep several alternative plans. You pick course of action B instead of course in A, C, or D. You schedule a review after a designated interval, and if it's not converging the way you think it is, look at changing the plan. This has really important leadership challenges because you've got to convince your boss that when you schedule this leadership review, if it dictates change, that's a sign of strength, not a sign of weakness. Same thing, you've got to talk to your team. It says, when we're going to pick course of action B, I expect 100% support for it, but if we find a review and it dictates change, that's a sign of strength, and I expect your support then for the new approach. You have to build that leadership challenge in from the beginning. And again, engage outside coalitions. Cyber resilient organization, this is kind of senior leaderships have to address this. These are a lot of things the board should take a look at, or the command. You have somebody in charge of this. Are they empowered to do it? Skeptical, trust, but verify. But this is important. Move the goalpost about every 3 years. That business about being resilient for the new environment in which you're facing after the crisis has really got to be a new environment. And you can never stand your laurels and say, okay, I'm resilient for the next 10 years. The world is changing too fast for that. So how do you adjust for, every 3 years or so, look at the goalpost where your organization is aiming for and think about adjusting it because the world is changing around you. So finally, one of the next steps, first of all, realize that true talent in this space is really scarce. People talk about how we're training all these cybersecurity people. Well, this is a scale-free network, okay, and this random distribution. The scale-free network turns out to describe a lot of things in physical life, like this describes almost exactly the percentage of aces among fighter pilots. Okay? The number of really first-rate billiards players or stuff like that. It's going to describe the number of really good cybersecurity people you have. And just because somebody has a CISSP after their name does not mean they're going to fit in this category. So how do you find a way to identify those people, recognize them, and keep them? The guy whose company won the Cyber Grand Challenge at DEF CON, the prize was $2 million. And the question was, how are you going to use this? You can put it back in your business. He said, I'm going to take 80% of it and pay it bonuses for my people to keep them being hired away by Google. So then I'll put the rest back in the company. Okay, AI and machine learning, there were about 600,000 people short in the United States alone on cyber secure capabilities. We've got to find a way to use the AI to bridge that shortfall. I mentioned the height. But also remember, the AI and machine learning algorithms themselves are vulnerable. I don't see nearly as much attention, I think, as there should be on the cybersecurity of those algorithms. Train tough scenarios, how to use big data analytics, people, and again, the OTIT intersections. Comments, queries, please. Thank you. Nothing? Sir.
I always have questions. So it's not a very pretty picture.
No.
It's not a very optimistic picture. I'm wondering two questions. So, and I'm sure this the answer to this question will not be published in detail. But if you take the US offensive cyber capabilities, and you ask the question, what would happen to our civilian infrastructure if an adversary with the same capabilities applied on the civilian infrastructure? What would happen?
No, actually, I heard this asked yesterday. And this was particularly in the context of that the U.S. has said it's going to employ whatever it is, offensive measures against anyone perceived to be interfering with the election. And the question was, okay, suppose somebody responds against our infrastructure. And the answer was, in this case, the answer was that's a risk we'll have to take at this point because the election is so important. But I don't know many people who are really doing the serious risk-gain analysis because so much the infrastructure is owned by the private sector. And the power grids and all that are basically owned by the private sector. And I think in large measure, the government is relying on their self-reporting of their vulnerabilities, and almost certainly they don't really fully understand their vulnerabilities against these kind of interconnected threats. But I think we have a really, really serious problem. And I think if you just look at how Stuxnet played out, okay, Stuxnet was a brilliant solution to a particular problem, but once it got the deal about what could be done, now lots of other things are vulnerable. So, I think a little bit like where we were back in the early 70s with MIRVs, in the sense that we had all this moving RV technology, and people talked about putting army control limitations on them. We got this technology not. Then by the early 80s, when the Soviets were deploying these large missiles with much greater throw weight, we realized that, and it caught up to us in the technology, that was not, we probably should have tried to limit some of this stuff. We had the advantage, but it's unpopular argument right now. Sir.
What's the first proposal that we should be writing out of the Center in Resilience then?
I think the first proposal is recognize that cybersecurity is not cyber resilience, and you need to think more broadly to get to resilience. And the cyber resilience only happens if you're part of an overall resilient organization. And so that's going to take you a little bit away from where the center itself says to deal with probably you're going to need some public policy people in here. You're going to need some more than just cyber people to get to that resilience organization.
That CRL.
Exactly. That's one of the points.
Really find those partners and get to work with them.
I think one of the points you have on the Navy plan
Uh-huh.
was creating this distributed islands. of
Yes.
security. So it sounds like you create a system that, so in computer science and computational systems, people have been working on these autonomous computational systems that are self-configuring, self-diagnosing, self-optimizing. So how feasible do you think to apply a similar idea to a broader cyber-physical infrastructures, which you might have a larger system, but if the system gets a hit, you have much smaller systems.
But that's the whole point about this cyber-secure microgrids. It's exactly the point they're trying to take, is that if the commercial power goes down, then these are really, really secure systems that can pick up the mission-critical loads of, in this case, bases. So I think the analogy is excellent and just right. I think we're at time.
Yes.
Thank you so much. Right.